So we're going to work on simplifying square roots. Is your paper the same as? Okay, yeah. So look at number 1. Number 1 actually comes out evenly. What is the square root of 16? 4. Okay? 24 doesn't work. So do I want the decimal or do I want the square root version? Well, if it said estimate the square root, thank you. If it said estimate the square root, that would mean find the decimal. But if it says simplify, when you simplify, you find the answer with the square root in it. Sorry, I'm trying to take roll. Okay. So what are two numbers that multiply to be 24? 6 and 4. 2 and 3, 2 and 2. What am I looking for? I'm looking for a pair. So I have a pair of 2s, and what do I have left over? A 3 and a 2. So for every pair, you bring out 1. So I have a pair of 2, so I'm allowed to bring out a 2. So 2 square root. I have a 2 and a 3 left over, so 2 times 3 would be 6. Yeah, this should be review. Okay. All right, the next one. 9 and 5, 3 and 3. Can I bring anything out? A 3. What's left on the inside? A 5. What about that negative? I. Where does the I go? It goes behind the 3, but in front of the square root. And the reason that we put the I there, if I put the I back here, is that inside or outside? It's hard to tell. So the I actually goes outside, but if you put it at the end, it's really hard to tell. So we always put it in front of the square root every time. Okay, next one. 48. 6 and 8, 2 and 3, 4 and 2, 2 and 2. Do I have any pairs? Pair of 2s, pair of 2s. What about this 6 and 8 and 4? If they factor, then we ignore that they even existed. We only care about prime numbers. So I can bring out 2 sets of 2s. So 2 times 2 is 4. Square root of, what's left over? 3. What happens if everything comes out? Is that possible? What if we had 2 times 5 times 5 times 2? What can I bring out? I can bring out a set of 2s and a set of 5s. So what's on the outside? 10. What's on the inside? A 1, which in multiplication means nothing, so the square root cancels. And the answer is just 10. And actually, this would have been the square root of 100, which is 2, 5, 5, and 2. And we know that the square root of 100 is 10. What happens if nothing comes out? So what if I factored it and I got 2 times 3 times 5? Prime is the wrong word for it, but it doesn't simplify. So you just leave everything in. So 2 times 3 is 6 times 5. It's the square root of 30. If I factored 30, I'd get 2, 3, and 5. And nothing comes out, which means that this does not simplify. It's kind of like saying, simplify 3/4. Well, you can't. It's already simplified. Okay? Look at this one, 18x squared. So I have a 2 and a 9, 3 and a 3, and I also have x times x. Do I have any pairs? I have a pair of x's and a pair of 3's. So I bring out a 3x. What's left on the inside? Just a 2. nothing else. All right, the next one, 9 and 12, 3 and 3, 4 and 3, 2 and 2, and I also have X, 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 Z, Z, Z. What can I bring out? Well, I have a set of 3s and a set of 2s. Anything else? 2 sets of X's. Anything else? A set of Z's. And then my leftover numbers, I have a 3 and a Z left over. I'm forgetting one thing. I. It was a negative, oh, can't see it, but it's a negative 108. Where does that I belong? After the last variable, but before the square root. So the I is the last thing before the square root. So I pull out a 3 times a 2, which is 6. How many x's will there be? So x squared. How many z's will there be? 1z. And then my I. Square root of, I have a 3 and a z left over. So stay in your seats for a minute. I want you to work on this simplifying square roots. And after about, probably 8 or 10 minutes, then we'll start working on the rest of the worksheet. So finish the top half of that page. If you take a look at part 2, we want to find the roots of these two quadratics by factoring. So for the first one, what do I know about the signs? Both negative. Good. And can you think of two numbers that multiply to be 9 and add to be 6? 3 and 3. So x minus 3 and x minus 3. So what are the roots? 3 and 3. Do we need to list it twice? Nope. Once is good enough. So x equals 3. For the second one, we get x plus and x plus. Can you think of two numbers that multiply to be 36 and add to be 12? 6 and 6. So my roots are negative 6. What's that? It wasn't too bad, was it? Because you set them equal to 0. So you subtract 6 and you subtract 6. And you x equals negative 6 and x equals negative 6. Okay, first question asks, what is special about these quadratics? Ooh, they're not conjugates. Conjugates are plus and minus. This is plus and plus or minus and minus. So both of these, they have a single root. The first one was 3 and 3, and the second one was negative 6 and negative 6. Whenever that happens, we call these quadratics perfect squares. The reason they're called perfect squares, a perfect square is some number times itself. Like 16 is a perfect square because it's 4 times 4, or 4 squared. 25 is a perfect square because it's 5 squared. This quadratic is actually x plus 6 squared. And this quadratic is x minus 3 squared. And we're going to use that property to solve quadratics that we previously couldn't solve. Okay? So is it possible to have a parabola that only hits the x-axis once? What would that look like? How can you make that so it only hits once? Right, so this has, that has two answers, two answers, two answers, two answers. And notice those answers are getting closer and closer together. If the minimum is on the axis, then that quadratic has a single root. And sometimes we call it a double root because it actually happens, you need two of them to create the equation, but it only hits the axis once. Okay? So now in the space below, we're going to use the perfect square idea to solve these. Now this is going to look really weird, but it's going to help you with something we're going to do on the next page. So this is x minus 3 to the second equals 0. So write that down. Okay. Now, I can, well, this is the same one as that. So I already knew it was x minus 3 and x minus 3. So I'm going to square root both sides, and the square root cancels the square. What is the square root of 0? What times itself is 0? 0. So I just get x minus 3 equals 0, and now I add 3. And there's my answer. That quadratic hits the x-axis at 3. We're going to do the same thing on the next one. X plus 6 squared equals 0. So then I square root, and I square root and squared cancel. X plus 6 equals 0, subtract 6, x equals negative 6. Okay? Now, I want to show you a pattern that's really important. Do you see a relationship between negative 3 and those two numbers? And do you see a relationship between 6 and those two numbers? So how do I get from, what's the relationship between negative 3 and negative 6? What's the relationship between 6 and 12? Double. So whenever your quadratic is a perfect square, the middle term is double your factor. So middle term is double my factor. What about the last term? How does 9 relate to negative 3, and how does 36 relate to 6? It's the square of it. So the middle term is double, and the last term is squared. Okay? And, well, anytime you square something, it will be positive. So the middle sign matches this sign, but the last sign is always positive. That's a good point. Okay, turn the page. All right. Create a one-root quadratic with x equals 8. So if my root is 8, what are my factors? Perfect. X minus 8 and x minus 8. Well, roots and factors always have opposite signs. Because if I was to go from here to here, I'd set it equal to 0, and I'd add 8. So yeah, roots and factors always have opposite signs. All right. Well, this is a perfect square. So I know the pattern. X squared. What do I know about the middle term? It's double the 8. So minus 16x. What do I know about the last term? It's the square of the factor. So plus 64. And the pattern, what's the relationship? The middle term is double, and the last term is squared. So we're going to do a little trick. So you can put your pencils down as soon as you finish writing that. What happens if I give you part of a quadratic and you don't know the last term. Can you figure it out? So if I gave you x squared plus 4x, can you tell me what goes here to make it a perfect square? Nope. So I need to know what goes in here first. This would be a plus 2. So plus 2. And if that's a 2, what would this be? 4, because it's 2 squared. Okay? What if I had x squared minus 10x? What would go in here? Negative 5. Because this term is twice as big as this term. So x minus 5. If that's a negative 5, what goes here? Negative 5 times negative 5 is plus 25. And you might want to pay attention to the signs. If this is plus, this is plus. If this is minus, but the last term is always positive. So let me show you what's going on visually. So these are called algebra tiles. So if I had the equation x squared plus 6x, so x is an unknown distance, so that's my x, and I can change the size of x. And this is 1. So the area of this thing is x times 1. So if I had the equation x squared plus x squared would look like this. X times x. And then I would have 6 of these. X, x, x. Is that 6? Yeah. So let's arrange those and try to make a square, a perfect square. I don't remember. There's got to be a way to rotate them. Hold on, let me bring this back. No, that didn't work. X squared. Oh. Hold on. Okay, that's how you do it. Okay, so x squared, and then, so these 3 go there. So in order to create a square, how many singles do I need? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now it's a perfect square. So over here, if I had, this is going to be really bad handwriting, sorry. If I had x squared plus 6x, what number goes inside here? 3. And what number makes it a perfect square? Plus 9. Does that make sense? So if I tried to do this problem here, so clear that out. Here's my x squared, and I'm going to add 4 x's. So I'm going to try to create a perfect square. How many singles do I need to make it a square? 4. Is that what I had? Yeah. X squared plus 4x plus 4. Okay. Well, what about the subtractions? What if I had x squared minus 8? Well, I don't know how big I can make it. I want to go anyway. So let's say x squared minus 2. So I'm actually going to take 2 away? Well, if I take 2 away, I subtracted this off twice. So I need to put 1 back in to make it even, and now it's a perfect square. Does that make sense? Because if I take this away, and then I take that away again, I subtracted this off twice, so I have to add 1 back on to make it balance. If I had x squared minus 4x, how many do I have to add back on to make it work? 1, 2, 3, 4. Okay, that's what we're doing. Okay. So if you look at part 4, oh, that's wrong. Oh well. Is that equation the same as yours? Okay. So, is this a perfect square? Well, if we ignore the 20, what would go in here if the middle is negative 8x? Negative 4. And then if that's a negative 4, what should that number be? A 16. So this one doesn't actually work. What we're going to do is force it to work. So here's my first step. If I want to find the roots by completing the square, I'm going to move the 20 to the other side. So I'm going to add 20 and add 20. So now I get x squared minus 8x, and I'm going to leave a space for that number that I need to add, equals 20. And we decided that this should be x minus 4 squared. And what number goes here? Plus 16. So everybody has to understand this before I go on. And it's really not hard to do, but for some reason, a lot of kids make mistakes on the test. So first step, take the 20, put it on the other side. Next step, rewrite, leave a gap, figure out what your factor is, and using that factor, create the perfect square. Now, an equation is just a balance beam. If I add 16 pounds to one side, it's unbalanced. How am I going to make it level again? Add 16 to the other side, and now it's in balance. So over here, I also add 16. Okay, so now I have x minus 4 to the second equals 36. Now I can find the roots by taking the square root. So square root this and square root that, and I get x minus 4 equals what? 6 is not totally correct. Well, if you square root an x squared, you always need plus or minus. Plus or minus 6. Yes. Okay, so now we're going to add 4 and add 4. What is 6 plus 4? 10. What is negative 6 plus 4? Negative 2. All right, put your pencils down again. I'm about to make you really upset. Remember those answers. All right, let's try to factor this. X minus and x plus. Can you think of two numbers that multiply to be 20 and add to be 8? 2 and negative 10. So what are my roots? 10 and negative 2. We got the same answer, doing it the easy way. So if I go back, why did I do all that work? Well, there's a really good reason. If my quadratic touches at 10 and at -2, then I can factor it. But what if it just barely misses the 10 and the 2? What if it's like 9.8 and -1.8? Then it won't factor. Also, what if it misses the x-axis entirely? If the roots are imaginary, it doesn't factor. Factoring only works if the answers are whole numbers or fractions. Completing the square will work every time, no matter what. So we're learning how to complete the square to help us solve quadratics that we didn't know how to solve before. So this one ended up being really nice numbers, but that's not always going to happen. For instance, look at the second one. So my first step, move the 45 to the other side, and then rewrite. So x squared plus 12x, I'm going to leave a blank, equals -45. Okay? What is my factor? X plus 6. Good. Squared. What is my perfect square? 36. So now I have x plus 6 to the second equals -9. Now I take the square root. Oh, that's an equal sign. And I get x plus 6 equals, what is the square root of -9? 3i. And don't forget the plus or minus. Plus or minus 3i. So to find x, I subtract 6. How do you mix real numbers and imaginary numbers? You can't. So my answer is x equals -6 plus or minus 3i. Would that quadratic have factored? No. In fact, that quadratic doesn't even touch the x-axis. So these are imaginary numbers, which means that the quadratic is up here somewhere. So it used to have no solutions, but now we have a way to find the solutions. So if you turn to the next page, and here's your worksheet. So don't work on page 2 tonight. Your assignment today is to do the first 3 problems, 1 through 3. And it's that same process. Move this number to the other side, rewrite, leave a space, find the factor, add that number to the other side, and then take the square root. So you have 3 problems to work on tonight, and we'll finish this worksheet tomorrow.